Hello everyone. Today I am going to explain you the topic algebra of real functions. So, what is a real function? We already know that a real function is a function in which domain and the range set is a set of real number, or domain and range set is a subset of real number. Then that function is called a real function. Now let us take two real functions and we are going to apply the algebra on the real functions. So first is addition of real functions. Addition of real function. Let us suppose there is one real function f from a set x to a set of all real numbers, and let us consider another function g from a set x to the set of all real numbers. Clear? These two are clearly, these are real functions because their domain and the range set is a subset of R or a itself real number. Here x is a subset of real number. Now defining addition of these two real functions. So addition of real function is written in the form of fx plus gx, where x belongs to set x. It is also clear that f plus g, addition of two real function, is going to define from a set R to the set x to the set of real numbers. So this is a definition of addition of real function. Now second is subtraction. Subtraction of real functions. So how we can subtract two real functions? Let us suppose we have a real function f from a set x to a set R, and another real function g from a set x to a set of R. Then their difference of these two real function f minus g is again from the set x to the R, and it is defined as f minus g of x is equals to f of x minus g of x, where x belongs to capital X, set x. This is the definition of difference of two real functions. Now third operation on the real function is scalar multiplication. Scalar multiplication by a real function. If we are multiplying a real function by any scalar, then how we can apply the operation on it? Suppose we have a function, real function f from x to r, and here alpha is any scalar, any real number, then the product of this alpha f is again from the set x to the set R, and the definition of this function is equals to alpha into f of x. Simply we have to multiply a function value by a scalar alpha. We can get the definition of alpha f function, where x belongs to capital X. This is a definition of scalar multiplication by a real function. Now next type of operation is multiplication of real functions. Multiplication of real function. Similarly, I have taken f from a set x to a R and g, another real function, from a set x to R. Then their product is f dot g. This is a product function which is again defined from x to R, and it is defined as f dot g of x is equals to f of x dot g of x. Simply we have to multiply the function value of f and function value of g. We get the f dot g, multiplication of two real functions where x belongs to x. This is the way. Now next is quotient of real functions. Last is quotient of real functions. Again, this f is a function from x to r and g is a real function from x to r. Then their quotient is f upon g. This is the definition. This is called quotient of functions f and g of x. This is given by f of x divided by g of x, where x belongs to set x. And there is one condition, we have to take this gx is not equals to 0, because if it is 0 for any x value, then this will become infinity, which is not defined. So we have to conclude one condition here, that gx will be not equals to 0. Gx is never be 0 for any x. Then we can define a quotient of two real functions. Thank you.